pH indicators are chemical compounds that change color as a result of the concentration of acid. To prepare a pH indicator at home, you can use Red Cabbage, which contains anthocyanins, giving Red Cabbage its distinctive purple color. That purple color will then change depending on if it is in an acidic environment or a basic environment, and the concentration of H+. To prepare the indicator, you will need Red Cabbage, a couple of containers, either bowls or glasses. In general, it'd be nice to have a piece of filter paper or a coffee filter and some hot water. To begin with, you can take your Red Cabbage and cut it up into some smaller pieces. You want to contain as much of that red color from the cabbage as possible. So try to avoid the large white core of the cabbage itself. You don't need too much Red Cabbage for it to display a color. I'm going to cut a couple of cups of Red Cabbage just in a few pieces. And you can see, especially after or below the outside leaves, the very vibrant red color of the Red Cabbage. This is the pH indicating compound. You can then take this Red Cabbage and place these pieces into a container. Again, either a large glass or a bowl. After which, you can pour in some hot water. The water itself does not necessarily need to be boiling, but should be quite hot to the touch. Usually you can get this by an electric kettle, or on the stovetop, or in a microwave safe container you can heat up some water. Typically hot water from the tap is still a little bit too cool. So be very careful with the hot water, but once you have the hot water, you can then pour this over your Red Cabbage. As you can see, the color of the cabbage is now being extracted, that is being removed from the cabbage, and the water itself is now becoming that purple color. This is a chemical process known as extraction, and it's used heavily in chemistry labs. Over time, more and more of the anthocyanin compounds are being removed from the Red Cabbage itself and extracted into the water. You should let this sit for a few minutes while the water cools down. The longer you let this sit, and the more exposed purple areas of the Red Cabbage, the more intense your pH indicator solution will be. Once the solution is cooled down and it's been sitting for approximately 5 to 10 minutes, you can then filter it using a coffee filter. After the Red Cabbage and hot water has cooled down some, you can then separate the liquid component, which has the indicator extracted into it, and the leftover cabbage component. Most times you could probably get by with taking this and holding back the cabbage and pouring it into a different container. That should work for most of the material. However, you could also use something like a coffee filter to filter out any fine particles of solid. By using a piece of filter paper, you can typically get rid of a lot of fine materials, and you can see it funneling out through the bottom. Filter paper is used a lot in more of a qualitative setting where you're trying to separate out varying sizes of solid components. In labs, filter paper could have very small pore sizes that blocks most solid material, even small solid particles, but it would typically take a longer time for the liquid to flow through. Things like a coffee filter at home will filter things very quickly, but very fine particles could still pass through the paper. In something like this, it's going a decent speed, and you can filter a lot of material through that. Either way, whether you're just pouring it off or filtering it through a piece of filter paper, in the end, you'll have a dark liquid solution which contains all of those anthocyanins, that indicator that changes color with pH. And you can then use this indicator solution to test a number of different household solutions. With the indicator solution prepared, you can now test this indicator over a number of different solutions. The color of the indicator is an indication of what the pH is of the solution. That is, what is the acid level of the solution. Initially, at approximately pH 7, when you prepare the indicator, it should be a purple color. And starting with a low pH and working to a high pH, we can see what are the changes associated with the indicator color. First, beginning with a pH of 0, this is a 1 molar solution of acid, we see that the color is a darker or deeper red or red-orange type of a color. Moving on to pH 1, it looks very similar. pH 2 seems a little bit lighter. It is no longer as deep, darker red color, but more of a reddish pink color. Moving on to pH 3, we see it's getting a little more pink, a little less red. pH 4 is very much pink, not really too much red anymore. pH 5 is about the same. pH 6 is getting more of that pinkish, a little bit more blue associated with it. pH 7, we have very much the purple color, a little bit lighter in this because it's not as concentrated. And then moving on to the basic side, we have pH 8, which you see is a little bit more darker purple. It's moving on to a little bit more blue color. pH 9, much more blue, less purple, so it's getting less and less of that red color, and now it's much more of a blue color. pH 10, you now see a very distinct color change where it went from a blue to like an aqua type of a color. pH 11, it's losing some of that blue and going into a much more green type of a color. pH 12, you still see that green color. pH 13, you see the green color to start, but you can see that it's a little bit more yellow than initially than the initial color. And it will fade a little bit more towards yellow over time. And pH 14, you see it start with that green color and now move to that much more yellowish green color. So this one indicator from the red cabbage can vary the color that you see based on the pH. Going from a darker red color in acidic pH through a pinkish color to a pinkish purplish color in a more neutral pH to a blue color to a little bit above neutral pH into basic, going to green, and then finally in very basic conditions you see the yellow color. Using these indications, using these colors, you can use the red cabbage solution to figure out what is the approximate pH of varying different components or various different solutions that you can find at home. Is the solution acidic? Is the solution basic? And in an estimation of these colors, approximately what is that pH? When using the pH indicator from red cabbage to test vinegar and its dilution, at home you're going to be preparing a dilution of vinegar. Vinegar itself is a 5% solution of acetic acid. A percentage of a solution would be grams per 100 milliliters. A 1% solution would be 1 gram per 100 milliliters. With a vinegar solution, this would be 5 grams for every 100 milliliters. And from that ratio, you can determine the actual molarity of vinegar using the molecular weight of acetic acid, which is 60 grams per mole. With the molarity of the vinegar known, you can also use that to determine the molarity of your dilution. At home, you're going to be using 1 tablespoon of vinegar and 6 tablespoons of water. 1 tablespoon is 14.787 milliliters. So this is a little bit under 15 milliliters. A little more. Okay. So you'll have your 1 tablespoon of vinegar and then 6 tablespoons of water. So each tablespoon is 14.787 milliliters. So there is the first 50 milliliters. And then the remaining. I am approximating to 15 milliliters. So now I have vinegar, which you can determine the molarity for, and a dilution of vinegar, which you can determine the molarity for based on the initial molarity of vinegar. You can see that when I take this indicator solution and put it directly in the vinegar, it becomes that pink color, kind of a deep pink. You can look at the image in the slides to determine what, or in the previous video, what is the approximate pH of vinegar just based on the color itself of this indicator. At home, you'll also be looking at what is the color of the dilution and comparing the two. You can see the molarity of vinegar, you can look at the pH of vinegar, And from the pH, you know what the concentration of H plus is, the concentration of the acid. If you know the total molarity of the vinegar and the total molarity of H plus, you can see what percentage of the vinegar, what percentage of the acetic acid breaks apart into its separate ions to figure out the percent ionization. And use that value to calculate what is the concentration of H plus in your dilution. When I look at the dilution itself and add my indicator, you can see it is still a lighter color. I added 3 of these, so you can compare these two colors. You see the darker red solution of vinegar, which is a lower pH, a higher concentration of acid, versus the lighter pink color of the dilution, which is a higher pH and a lower concentration of H plus. When testing the baking soda solution at home, you're going to be performing a serial dilution. That is, preparing one solution and then taking some amount of that, performing a dilution, taking some amount of that, performing a dilution, some amount of that, performing a dilution, and so on. At home, you're going to be using 1 teaspoon of baking soda powder, which weighs 4.800 grams. And to that mass of baking soda, you can add in 7 tablespoons of water. This is 103.5 milliliters. So I have 50 milliliters. You see it's starting to dissolve. (100 milliliters). And then I have a calibrated pipette to add in another 3 milliliters. So now I have a solution of baking soda. Initially, it might not be fully dissolved. You see it's still a little bit cloudy. So you might want to stir this up a little bit just so that it fully dissolves. With the mass of baking soda powder, which is pure sodium bicarbonate, and the volume of the solution, 103.5 milliliters, you know the molarity and concentration of your baking soda solution. You can then take that and add 1 tablespoon of your baking soda solution to the first dilution. That would be 14.787 milliliters. Or as I'm using a graduated cylinder, instead of a tablespoon, I'll be using 15 milliliters. Okay, so I have 15 milliliters of my baking soda solution. And then it asks for 6 tablespoons of water, which is, with my approximation, 90 milliliters. So here's the first 50. And then the next 40. So this is now the first dilution of baking soda. You can then go through and do this for the rest of the solutions, starting with this dilution, solution number 2. You'll take 1 tablespoon of that. In a glass, and then 6 tablespoons of water. I need a little bit more water. So I had my first 50 milliliters, and now I'm adding the other 40 milliliters. To make my second dilution. So initially I have a solution of pure baking soda water. I made a dilution of that baking soda water, and then a second dilution of my first. So going through, you're going to make 5 different dilutions of your baking soda water and then use the indicator to test what is the actual color and what is the pH of your baking soda solution, as well as all of the different dilutions. Once all of your dilutions are prepared, you can then look at what is the pH of these 6 different solutions using your Red Cabbage indicator. The pH of the baking soda solution itself, you can see, gives that bluer type of a color. And as you move on, it becomes a little bit lighter, or a little bit, just a little bit different. So you're going to be going through and looking at that, at all of these dilutions, to see how that pH changes over the course of the concentration of baking soda. Moving on to the next dilution, we see it's changed a bit. It is no longer that teal color. It is much more of a bluer, much more of a blue color. Going on to the lower dilution still, it changes again and is less blue and is now more purple. If I keep going, it seems, again, just a little bit pinker than it was. And at last, it looks to be about the same. You're going from the basic solution, the basic baking soda solution, through a series of pHs to reach what is approximately neutral.